The best definition I have for it is that surveying is the art, science, and technology of making measurements on the Earth's surface.
For the companies that don't have surveyors, when is it necessary or when does that cross the line on surveying?
Historically, we are always the first people in. We have provided the entire project control.
Starts when we're doing the boundary at the beginning of the project, and we're setting control for the topographic survey on the exterior of a build site.
If 2 or 3 inches is accurate enough for your project, hey, great, go for it. How do you know you're within 2 or 3 inches?
Are they going to accept it if it's out 1/10 of a foot? Or does it need to be just a couple millimeters?
Sometimes even the reports are like, yeah, this data looks good. You slice the data and you see there's 2 floors or there's 7 walls.
Trial different layouts of ground control points, shooting those, reprocessing and seeing what that data actually does elevation-wise, horizontally.
Every state has different regulations and they usually draw the line at control.
Knowing what your state regulations are and staying within those boundaries so you don't get your hands slapped.
A municipality that requires a survey in order to get the permit to begin with, and what are their standards?
I think it's something that is undereducated and talked about is the importance of the survey.
Educate the people that are using this unbelievable technology that's insanely accurate.
Educating your client as to what the product is and the accuracy that they can anticipate from that.
Really do need to understand what are you providing and how you're communicating that to the client.
What tool? What's the use case?
There's some things we need to learn and understand so that you can have repeatable data time and time again.
Being upfront about what it is you are selling versus if you have a surveyor involved in what the product is.
It's important to just know what tool to use when.
In most cases, folks that are using this equipment, they don't know what they don't know.
As surveyors, we are very familiar with a term called error propagation and how quickly error can accumulate.
If you get a little shift in that scan data from the boundary data, from the exterior topographic data, you're going to have trouble.
These guys did 3,500 scans and not a single target or control point.
They never asked the question, well, what is this going to be used for? And there was vertical error everywhere.
We have a lot of people in here that have big buildings to scan. You don't want to have to go from 3rd floor to basement.
Are you trying to sell accuracy or are you just trying to sell a pretty picture?
If you don't have that control or you've never done that process, you don't even know that that's an option or why you would need it. You wouldn't have known that your building's tilted in the point cloud.
Not every single scan needs survey control. It depends, in my opinion, on the deliverable, what the requirements are, if your tolerances are plus or minus a foot.
Throughout construction, we maintain that control and maintain the integrity and the accuracy of the control throughout the project because things change throughout a project.
People that are coming in this industry and don't necessarily get that feedback from professional land surveyors, professional engineers, they don't ask the right questions.
Probably the biggest challenge we still have is find qualified people, find people that are interested and educated and want to really engage in this profession. I think that's the biggest challenge that we face.
All of those are going to have the same issues on a certain scale of projects and certain types of projects without survey, period.
We've continued to have this conversation of what is the survey industry's role in all these new technologies? And some of us, I would say, in the industry have learned things the hard way. We don't know what we don't know, right? There's people who get a tool and they go out and start using it. And then later we find out, I have all these errors or there's issues so we love having this panel to kind of have this conversation around how does the reality capture industry in whole work alongside the survey industry and what does that relationship look like? So before we get going, we're going to do some introductions real quick and then we'll jump into this conversation. We'll start down here.
My name is Mike Falk. I own Falk PLI Engineering and Surveying. We've got 45 employees in 4 offices. And our company introduced laser tracking and laser scanning into the metals industry 25 years ago. And I first used the technology in the early 90s at a federal laboratory in Texas. So we've been doing it for a while.
Awesome, thank you.
Mike Griffith, founder and CEO of Ozone Reality Capture, based out of Southern California. I work with an incredibly talented team of LiDAR specialists, drone pilots, and land surveyors.
James Harbin with JTM Construction. I spent 5 years as a party chief, and now I'm the survey superintendent. We run survey on our job sites and reality capture. I have a great team. Some of them are here today with us.
Dolly Carwile, president of McGillivray & Co. Surveyors and Mappers, located in Florida. We are currently providing support to many firms that require reality capture for drones and scanners and providing BIM models in addition to traditional surveying.
I'm Rami Tamimi. I'm a PhD student at The Ohio State University studying surveying and geodetic engineering, and most of my research revolves around utilizing fundamental survey principles and incorporating with new geospatial technology.
Hello, good afternoon. My name is David Acosta, and I'm the owner and president of CSTI. We're a land surveying and geospatial company out of New Mexico. So really excited to be here and look forward to conversing with everybody.
And I'm Trent Keenan, owner of Diamondback Land Surveying based out of Las Vegas, Nevada, but we do kind of work all over the West Coast. Similar, we've had some type of 3D scanners for well over 10 years, starting with kind of the Faro and some other stuff, and then have transitioned to newer technologies as things have emerged.
Awesome. Okay, I'm going to go back to my first question, and I know I didn't announce this early enough at the last panel, but we did still get some Q&A in there. You guys do have the QR code. If you'd like to submit questions throughout the panel, you're welcome to do so, but we're going to start with just some conversation up here. So the first question is, what is the land surveyor's role in the reality capture industry in whole, and what should our community as a whole that maybe is not majority licensed surveyors, what are things they should be thinking about?
Well, I know my firm, we provide the support that people that are doing the capture need to get accuracy and to relate it to their control to other plans so that it all integrates seamlessly and you don't have drifts and errors.
I think a surveyor's predominant role is to make sure the data is not just a pretty picture. We take a look at the analytical side of things and ensure that the numbers all match up to what exists in the reality of the world. Sometimes people get hung up on certain numbers saying, oh, well, based off of this math equation and based off of that math equation. And a surveyor is here to bring everything into reality and to show you that, hey, the evidence of the earth shows us that this is what the number should be. So I think that's what we are specialized in.
Yeah, just to add on that, we take some extra steps to make sure that the accuracies are understood when approaching a project, and when we're dealing with typical GPS-derived survey control, and then we have a 3D model derived from laser scanning. There's different types of errors and accuracies to consider. So I think we kind of oversee, how that process all takes place, being that typically we're going to be the ones stamping it in the end. So.
And it goes back to the main fundamentals, right? Making sure that the 3D scan data is on the right property, right? We can go back all the way to the surveyor's fundamentals and making sure that we're protecting your client's largest asset and make sure it's on the right parcels. And that's outside of control or blending datas and then things like that. I mean, our job is to protect the public and their asset. So
it's the starting point.
Yeah,
it's the building block that we come in after and work off of. So
yep.
I guess the thing that I would say is that if we don't get too caught up in the technology, it's just a tool.
Mm-hmm.
And there are various scanners out there that you can achieve different precisions or accuracies. And it's understanding the right tool for the right job. There are scanners right out here in the tech sessions areas where we've actually, if you've never seen an error of closure on a point cloud at 0.000, I can tell you how to get there. And using laser trackers, we typically measure down in the thousandth of an inch range. Unless we're in a laboratory, then we're down in the 2/10,000ths of an inch range. And we've had Faros and scanners and Leicas, and actually the first scanner I owned was a Cyrax. And it's understanding the workings of the system. And the last thing I want to do is admonish anybody that's not a land surveyor, but realize that we're all part of a group and we're all part of a team, and that we all bring our own talents. And that's what I appreciate about everybody here.
Yeah, I think a lot of times it's hard to keep up with the technology also because it's just constantly evolving. And so it's good to have that collaboration, because there are, some professionals out there who focus strictly on laser scanning. And so there's a lot to be learned from them as well. We were having a discussion earlier, and it's, trying to find people that have those skill sets, that have that understanding to talk to is very valuable for anybody. It doesn't matter whether you're licensed or not. If you know how to use this tool, then you know how to use it. So, it's really great that we have this opportunity to have this collaboration and this discussion, because if we don't, then there's going to be a lot of information that could be missed on both sides.
Absolutely.
And through initial discussions with the group, I realized we were unique in that we started with tech and then brought licensed survey in-house, where you guys are licensed surveyors first and are adopting the tech. I think it's really important to bridge the gap between the old and the new and gain trust in the technology. And having a LS that has been in surveying 48 years and teaching him the technology and validating and proving out that we hit our marks each time, I think that's proving to the industry and helping foster adoption.
Absolutely. Good point. What do you think about the reverse? So as part of the survey community here, how important do you think it is that the survey community starts embracing technologies? Because I think that's another question mark that we sometimes talk about, right? Is that even the survey industry has certain struggles, I think, in attracting talent. Some of the things that were talked about in previous years is the survey industry has a lot of people retiring out, yet they're also the experts in measurement. How do you see the importance of the survey community getting in with the technology side, and how that's like affecting your guys' business or what you see happening in the survey industry?
I'm sad to say that in Indiana and Illinois, the average land surveyor is my age. And I'm glad to see some younger faces up here on the stage. The thing that I would encourage everybody to do is, when you buy the technology, I heard earlier today some people talked about, and I'm not going to get into any unfair labor practices here, okay? I'll keep you safe from that. But when it comes to pricing of what you do, I think you really need to look at the value of the product you're bringing, and not how many hours or what kind of cost it took you to make that. Obviously, you want to make up your payroll and you want to make up your overhead to cover the price, but there really is a value to this stuff. One of the things that we do from a surveying perspective, we rarely model anything because we want to deal with all the data. And the surveyor part is, if you look at error propagation, and you've got systematic errors, random errors, and blunders are the three types of errors that they put together. And the way you get rid of random errors, you take a lot of measurements. And what is a laser scanner but taking a lot of measurements? And if you scanned this room and only took the bottom quarters of the floor and said, this is what our room looks like, you're going back to old school surveying. What's all that other data trying to tell you? And that's where we can bring things in. And that's how we have to look at and embrace technology.
Surveyors need to be faster at adoption of technology, right? I mean, it's been the issue in the survey profession forever, is to be kind of behind the times and never keeping up, because we talked about it in a few sessions here. Everybody's so busy, and surveyors, minus a couple of downturns, have always been busy, right? And so in the earlier sessions where I'm comfortable using this tool because I know I get the correct answer every single time, and they don't want to take the time to learn something new, right? And so the biggest importance is just adopting faster, and that's just something that the profession has never done. And through that is getting the surveyors to use the latest and greatest technologies so that we can attract the younger generation and the younger kids, right? That the gaming kids and the ones that have that AI mind, and we have a couple at our office that are just totally in on. He wanted to be a robotic engineer, and we've kind of harbored him into play with the AI, play with the 3D models and that kind of stuff. So it kind of uses that robotic brain of his. So, but until we adopt, we're not going to be able to attract.
Yeah, if we don't embrace it and wrap our minds around it and then have a passion for it and share it with everyone that we know, then we're not going to attract younger people into the profession.
I liked what you did because you've encouraged someone who's young and ambitious to take a certain interest that they have, whether that's AI or machine learning, and you've implemented it into your business, into your work, and you're going to be the one that reaps the benefits because this young and ambitious, we'll call him a surveyor, this young ambitious surveyor is looking for new ways to solve old problems. The problems are never going to be different. They're always going to be the same. Our industry is always going to be solving, the same problems. It's just now that we have these new technologies, we should be looking for more efficient ways to solve them. And these buzzwords, we hear them and we're all scared of them in some ways. But in reality, there's somebody behind that AI that's developed it. And that person that developed it has become very skillful and capable of enhancing your workflows. So surveyors absolutely need to be looking at newer technologies because it's only to their benefit.
I mean, the firm I worked at, they said they had too much liability to innovate. I got in trouble for laying out piles, shoring piles with a robotic total station. They wanted me to turn angles, set a point on line, and go down that line, and then for the offsets do the same. I can do it so much faster with a robotic total station. And I got in trouble and sent back out to do it the right way to prove it out. Right? They said you could have cost us a lot of money, and we're talking about shoring piles that aren't that accurate to begin with. They're temporary shoring piles, and they were afraid to innovate. And their reason was liability. They had too much liability to take the chance.
Well, something else that's holding us back as a profession from innovating is that the government is not keeping up with technology. So when we want to do things in a new, innovative way and collect data for them, they don't want it. They want something that's tried and true, regardless of however many arguments or proof of data and trials, that we can do it just as accurately another way.
I would caution you that the government is somewhat like businesses. I've worked for parts of the government that are really tight. And it's out there. And the government, just like businesses, are made up of people. And as much as we want to change, I'll tell you the thing that scares most people in the world is change. My colleague over here says he's too busy. I'd ask you to change your rates, raise them by 10%.
Absolutely.
See if you can work less for the same amount of money or more. There's nothing to be ashamed of being in demand.
Exactly. And that goes back to the point where charging more allows you to buy the equipment, right? And that's been part of the stigma of surveying is low rates, race to the bottoms, and not being able to invest in the newer technology because they don't have the money in the margins.
That's a great point. Earlier today, people talked about, do you have an R&D budget? I would tell you how much of your R&D budget is billable and how much of your R&D budget is overhead. Because as a professional, people hire us to solve solutions based off of our experience, come up with solutions based off our experience. That means every time we do what we think was the same task we did yesterday, we look for that little tweak where we can make it better. That's R&D. Bill your clients for it.
Yep.
Love it. There's actually quite a few questions coming in. I'm going to intermix these as we keep going. One of them, so I think I talk to a lot of people. And I would say if I had to guess, there's probably 5% of the people that would attend here would have like a licensed surveyor on staff. That's my guess. I think that there are a lot of companies, so architecture, construction, all kinds of people that are adopting scanning, that are going out and doing scanning that don't have survey. And I would say a lot of them don't even know how they would use it. They don't know why they would use it. And so I think, one, I'm really trying to push the education around why we need survey, why we need control, how errors are built up with the different technologies. But this is a question of, how would a scanning service provider as a scanning service provider, what is the essential information that a surveyor would need to be able to assist you with the project? So we've got these companies that are out scanning, and they have this feeling, they hear people say, survey is important, accuracy is important, you're not gonna achieve it without, but they don't know why, and they don't know what their errors are gonna be. Why do they need a surveyor, or how would they collaborate with one?
Oh, I would speak from experience and hopefully help the person that asked that question. We were in that very same space at one point in time, and I think networking within the industry, your local, like for us it's CLSA, networking, getting to know those folks, finding a mentor, being comfortable asking questions, and them providing you with accurate information, saying, okay, this is how I like to see it. This is how you validate your data. For us, that was incredibly important before bringing survey in-house. Yep.
Mm-hmm. And I think it goes back to the surveyors as well, having an open mind, right? If they can't invest in buying a scanner, which we chatted upstairs about, but if a survey company doesn't have the money or the capital to invest in the 3D scanner, create that network and create that partnership where you guys can collaborate together, right? They've bought the equipment, they're selling a service, surveyors want to kind of team up and be able to do that. And so it's having that open mind of being able to work together and not, again, that's part of a surveyor's issue, is not having that open mind enough to say, we don't want to talk about the whole GIS thing, but that happened 20 years ago where surveyors are like, no way, I don't want nothing to do with it. And here, there's a whole nother community outside of survey, right? We've heard that for 30 years already. But in the same situation, we're in another situation where surveyors don't want to team up with other, scanners or drones or whatever, and we're going to end up in the same boat. Mm-hmm. So if we don't have an open mind,
A well-trained, educated surveyor will know how to tell when his level isn't giving good data, when his total station isn't giving good data, when his GPS isn't giving good data, and a scanner. I mean, how many of us look at one scan relative to another to understand if our scanner's in calibration?
And you're not just looking at 2 scans, you're looking at 3 or 4. As a surveyor's mind, you're looking at multiple scans.
It only compounds, and the bigger the project, if you can ground truth your project with survey data. One of the problems that everybody's going to run into at one point or another when they just use scans and no survey data, they're not going to have dense enough or scans often enough, and they're going to have poor overlap, and it's going to cause the features not to connect correctly, and you are going to see some nasty stuff.
Mm-hmm.
One of my drone clients, he had a hard time getting any other surveyor to work with him to provide ground control for him. He works all over the state of Florida. It's kind of a no-brainer. We'll go out, we'll go over your projects, we'll set your ground control, you can fly it, and we'll keep going and doing, we'll both keep teaming up.
So you were the ground control?
We're running the ground control
Was
for
he
him.
Major Tom?
Yes, he is. He's my Major Tom.
It goes back to this morning, partnership, right? Find someone to partner with. We were talking about upstairs. Yeah, we have a small survey firm. We're very close with them, and we leverage each other. They can't afford yet to go out and purchase a scanner. We have them in-house. We do it as a service. They can market it. They can make a couple bucks off it. They're providing the control. All we're doing is collecting the data for them, and it, we can feed off each other, right? When we need support, they're there for us, and so it's an environment where we can leverage each other.
It's important to educate your client. Let's say you're a surveyor and you are working with a scanning company. It's good to educate them about the kind of work you do. I know lots of questions come up about coordinate systems. Okay, I just did this scan and it's in its weird coordinate system. What kind of coordinate system is that? Well, that's a local system. Oh, well, the client, needs this to be projected into state plane. How do I do that? Well, as a surveyor, I need that information prior to collecting the ground control. If I'm going to be doing some kind of processing, I need to be able to process that data so it'll be reprojected into that coordinate system. As a surveyor, I also educate them about different units. Not every state uses the same units, and I'm sure if you've been around long enough, you know that there's some states that use international feet, some use survey feet. So you as a surveyor need to have that knowledge and educate your clients so that next time they bring another project to you, they already know what they need
and you don't have to sit there and explain things or hide things. You've seasoned them, you've made them more knowledgeable, and that's better for you and for business.
Well, and since we have the PhD here, he can probably tell us about Transmercator state plane coordinates and how accurate they really are. And we work on a lot of projects where state plane coordinates don't guarantee the accuracy or precision that our clients need.
Absolutely. People will get really hung up, and I like to rip on some civil engineers sometimes because their industry is really, really big on accuracy, and they'll look at us and say, I need something projected into state plane, but I need it within 1/100 of a foot. Well, I sit there and explain to them, like, geodetic coordinates, the method of collecting geodetic coordinates, you can't get 1/100 of a foot. You know, you're looking at a local coordinate system using different types of tools. And so that's where the education part comes in. I start to explain to them what kind of tools they need, what kind of systems they should be using in order to achieve the outcome that they're looking for. And sometimes you can't achieve that outcome. You have to bring it back to reality, tell them, realistically, you should be expecting 3 to 4/100ths of a foot. So it all comes down to, you know, what the client's looking for and what can you provide for them.
And depending on the size of the project,
yeah, that definitely.
You've got to understand global coordinates and local coordinates.
Mm-hmm.
And a lot of times, we work on projects in facilities that will be miles long. And there is no way that we care about the distance from one end of the project to the other as some of those little parts in between we want to know very precisely.
Mm-hmm.
I'd love to get some feedback from the group. I think there's always conversation back and forth on, like, laser scanning should be surveying. And there's conversation about what should be required to have license to do or not. And I think everyone has different takes on that. And I'd love to hear some feedback from the group. Again, I think there's so many different uses for scanners. I don't think you could say laser scanning is surveying. But I want to hear the conversation around that of what do you as the survey community see, where do you see the direction of that going, or where do you think that it should go, and why?
I think first identifying what the project is. What is the scan data going to be used for? Is it just for a rough end that maybe an architect would be using, or is it something that's going to be used for an actual design? And I think starting with that is pretty important because, we could pull out our phone and go do a little scan, and, but what am I going to scan this whole stage, or am I just trying to scan a few dimensions that are very small? How am I going to use that information? I think is a good start because, we have some architect buddies that occasionally will let use our scanner, mm-hmm. right? And we work together, and I know how he's going to use it, and versus him going in with a bunch of interns and pen and measuring tape and going to get that kind of data where he could use a scanner for that purpose. Now down the road, as it develops, it could start to become part of a model, and maybe at that point, there could be a little bit more injection of the surveyor side of things to make sure that as that data gets to where it needs to be in the design phase, that it's gonna be checked and understood.
I don't want to get too technical or too political, and I don't want to scare folks away from pushing the technology forward and continuing to build relationships between technology and the survey community. But I'll say the state of California and the California Land Surveyors Act is very clear of what's land surveying and what's not. And they'll let you know if you're land surveying.
Not a surveyor. To get a quick cease and desist.
Most professions, as a professional engineer, you can survey work relative to your project. As an architect, the same thing. As a landscape architect, the same thing. Where the licensed land surveyor typically comes in is anytime it's related to a boundary. Now, some other states get a little more egregious than anything that has a geodetic coordinate. And I've been expert witness in some very technical engineering survey type things where land surveyors came in and tried to do stuff. And I guess the main thing I would not promote, I think there should be land surveyors in surveying. But first, I think they should take more of a leadership role. Because in 1988, I proposed doing a GIS for the city of Phoenix with the engineering company I did. And geographers did a great job with understanding what a GIS is, and surveyors made fun of it because it means get it surveyed. And what they didn't realize was that pretty little map you pull up on the internet nowadays for your county is actually just a visual system to tie all that information together that's in your courthouse. And if we look at what we do today in facilities, all that scan is really doing is pulling together all the systems within that building or that factory that we're working on. And it's just primarily, it's not about the scanning, it's about sharing the information and communicating.
And it goes back to your original question. It does, unfortunately, some states require, in Arizona, if you do anything that reports contours, then you have to have an LS on staff, right? So it's really state dependent and state law licensing board dependent. But is laser scanning surveying? It's just like you said in the very beginning, it's just another tool, right? And to collect the data. What surveyors do from a fundamental standpoint is we do the checks over and over and over, and the redundancy and the repeatable measurements. That's what we understand as the error. And so that's what I think what surveyors do differently than somebody who might be on the construction side or the architectural side where they're just setting up a scanner, doing one scan and walking away, right? Surveyors are trained to just do the redundancy checks. So.
I think the technology, will continue to move forward at a rapid pace as the professional community validates it.
Yep.
Right? You guys are the technical experts, and I respect the craft. And if you guys are saying it's good, then I think that says something for the technology and continues to move it forward.
Sure.
Yeah. The tricky thing about surveying too is that it's very vast also in itself. Mm-hmm. I have my certain expertise, and there's some parts of surveying that I may not step into because that's not really my expertise. So I think sometimes they talk about the licensure and how it could be broken into different pieces, maybe, highway construction surveying, boundary surveying. I think with LiDAR scanning, it's a whole nother world in itself. And some surveyors may not want to touch it at all, like we were saying, not scared of change or whatever the reason may be, but they just don't want to touch it or get into that world. And some choose to stay where they're happy or where their business is doing good and, don't want to try something else.
Surveying is very gray. There's no...
Hey.
It is.
I'm talking about you, but not you. Engineering is all very black and white. It either is or it isn't.
Yep.
This is our hard line. And surveying is we have errors and we have shades of gray.
I beg to differ. A lawyer friend of mine said, Mike, you're a typical engineer. Everything's black or white. And I said, no, you don't know many good engineers. Yeah, there's black and there's white. And there's a whole lot of gray in between. How much gray does my client want to pay for? Yeah. Now, the engineering in me will tell you that there's colors beyond black that we cannot see. That's the engineer.
So I'd like to pose again, so kind of from the perspective of there are a lot of people scanning who don't understand survey methodologies, tools, how you get a certain level of accuracy. So when we talk about the importance and how we as survey community can help improve that accuracy, for those people who don't understand any of that, the how, the when, the how accurate am I going to be without it, how do you recommend them choosing when do I need a surveyor? Is it if I have a project that's a certain level of accuracy being asked for? Is it a certain size of a job? How would you go about proposing and I know that most survey companies, I think, that are in these technologies have done tests and seen what does the data do without control? What does it do with control? So from that perspective, what kind of feedback would you give?
I think the manufacturers, if we can all come together and do a better job promoting what the tool is for, when to use drones, when to use scanning, when it's survey. It's not survey grade out of the box.
Nope.
Right? There's a special sauce to get from A to B. And I think sometimes we take for granted the power of the technology and assume it's going to do the work for us.
Yeah, I just because you said it's not survey grade out of the box, I don't call out names, but just 2 days ago I saw a LinkedIn post from a manufacturer of a drone that was like, it is a survey grade sensor, and I'm like, it was something along those lines, and my comment is like, survey isn't a sensor type. Like you can't say it's survey without how are you getting there? What do you
survey grade sensor on a non-survey grade platform.
So you can't just buy it and have survey data.
Yeah.
So how else would we recommend for companies that know they need accuracy? When do they get in with survey and how?
You need to know it's right.
Yeah, I was going to say, when it starts with what the accuracies are, what the end result of the data is going to be.
Yeah, if I have no control and I scan through this whole place, how do I know I'm right at the end? If I don't have control telling me that I'm right.
What's the level of detail that you're going for? What is the end purpose of the product?
If I need to see a good picture, yeah, okay, just go in there and scan it. But if
I know
you're
there's
actually
companies here that are doing fire route exits. They're scanning buildings to do fire route exits. So do they need for it to be accurate to within 2 or 3 hundredths? No. So do they need survey grade for that? No. Do they need it close enough to where they can figure out what the shortest route is to within maybe a couple feet?
Yes.
Sure.
Exactly. It's knowing the end result of what the data is.
If there's concrete involved being poured, they need a survey.
Oh, yeah.
There you go.
Yeah.
One of the things to start getting people to think about error propagation, very generally speaking, centering error, whether it's finding the center of the scanner or the center of the target or the center of the monument, you can kind of lump all the errors into that. And if you imagine I'm surveying a brass cap and I use a 5-foot pole or I use a 1-inch pole, the 1-inch pole is going to give me less error just from plumbing it up. Now, if I can find a way that actually force centers it on that point, it's even more accurate. So if I just start to think how I get rid of the errors, and one of the things that we found after a while was that anytime we did a scan or a laser tracking job and we didn't understand the data, it wasn't the equipment. The weak point was right here in what we understand.
I think the one thing that people misunderstand is that you can get some really accurate control, especially if you got a 1-inch pole. But if you fly a drone over it and then georeference that data, what do you need all that accuracy for? The drone's not even that accurate. Photogrammetry is not even that accurate. So you might spend all this time and money in super accurate control thinking that if I georeference to this accurate control that my entire data set will match. But the reality is all the different sensors you use, the data is going to assume the lowest accuracy sensor. So that's why we use GNSS receivers for like drone GCPs. You could use a total station, sure, but you're going to have pretty much the same accuracy because the drone is less accurate than both.
Well, has anybody ever set their scanner up on a floor that vibrates?
Wow.
And your point cloud looks horrible. Well, you let me know when a drone can be any more stable than a floor that vibrates. Right?
Great points.
Yeah.
So, and again, I'm kind of reading different questions, and we have different levels of experience of people here. So how do we reach a higher level of accuracy with our scanners by integrating survey? What is the method, or how do you incorporate control into a scanning job? So, and maybe you can even propose if you've seen some project examples of, like, let's say do we need control for a 10,000 square foot warehouse? Or how much error is somebody going to have if they go try to scan something like that without survey? And how do you integrate it?
Well, some scanning solutions allow you to set up directly over a control point, or be able to see it like that X right there, from the scan. So you're kind of incorporating the two already right there. When you're scanning, you have a relative model, and then you have the real world coordinates. So if your scanner check-in told you were in the 10,000th place, but you look at the residuals of the control that you're provided that was done with GPS, it may be to the hundreds. So it may be even overshooting in certain cases. So again, what is it going to be used for in the end, and how do you find that sweet spot to understand the two? Because you're not gonna get more accurate than the control you're starting off with to begin with, anyways. You can't get first order control off of a third order monument. So.
It's very project specific. What you're going to need. If you're inside of a warehouse, where are you setting your targets? What equipment is inside of the warehouse? What's going to be in the way? What are the environmental concerns, like your vibrations? You have equipment moving? Are you having active construction? Do you have a pile driver on your job site? Are you dumping dirt? All of those things are going to affect the accuracy and what you're going for. Are you flying a drone over thousands of acres instead of a warehouse? What kind of accuracy do we need for that? How many aerial targets do we have to set per acre? What kind of coverage do we have from the foliage? All of that's going to change based on the job. So if someone's asking this question, they need to sit down one-on-one with someone and say, this is a project I'm looking at. How can I take my scan that has some float and the floor on one end is 2 feet higher than the other? How can we fix that so that it's flat all the way across? That's a conversation that's going to be contextual.
There's some basic things that everybody can do to improve their survey. Take more scans closer together, and they can be shorter scans. Make sure you have the overlap. And if you, let's say that you've got 5 targets, because I just happen to have 5 fingers on each hand, and you've got 5 targets in each scan. As you start tying things together, you can over time get a minuscule little drift in that. And if you have a survey control program that runs down the middle of that where you can tighten it down, that's a bigger thing. Because I could show you instances where you can get better scan data than you can survey. And the real easy test for everybody to do is put a half dozen or so targets up on the wall, scan from here, scan from there. Tell your best total station guy to shoot it from here and shoot it from there. I guarantee you the scanner is going to be your total station guy.
From this distance, from the stage distance, of course. Of course.
And I can show you ways that I can have the total station guy beat the scanner guy. But there are some real tight procedures that you've got to do.
What do you think would be the truth for that in the end?
So, the truth of it is, when you scan from here and scan from there, scan from position A, you can put a baseline distance between all 5 points. You can do the same baseline difference over there, and then you can compare baseline number 1 from there and baseline number 1 from here. You can tell me the technical name for that, Doc, but it's what I still remember from 40 years ago.
Can't even remember their name for it.
And throw in there with construction, because I know a lot of us are in construction. Next time you're on site, ask one of the trade men or women out there, say, hey, you're off by an 1/8, and see what response you get on whether they're installing their column or they're putting a pipe in place. Pretty colorful answers sometimes. Tell them to adjust an 1/8 of an inch or 100th out.
I was going to say, you might end up in the concrete hole.
Or something might get dropped on your hard hat. No, it's, again, what are we using it for?
That's a great point, because every time you walk into a warehouse, are you just looking to see how many trucks I can fit in there? How many pallets I can fit in there? Are you trying to put an overhead crane in? Are you trying to put a paper line in? Are you trying to put in an aluminum processing line, an electro tin plate line? What are you trying?
And I was going to say, back to the point, I think knowing the end result, right? If you're just mapping a skyscraper for a fire route, plus or minus a foot's going to be great. If you're doing crash detection for HVAC, 3 inches is probably good, right? If you're building grid lines from floor to floor or pouring concrete and you need to hunt it, you probably want a surveyor.
For people that are interested in learning more, are there good resources out there on where they can look into how they would incorporate control, or do you recommend they just go straight to a surveyor and start having a conversation? How do they start getting into this?
I would say networking, right? Just building a network. It's been said all throughout the mentors, finding your mentors, finding your network, starting at local survey chapter meetings and starting, from a ground up, walking into a survey outfit and just having a general conversation, right? It starts with communication, and the best thing, anything in the world is all about communication, starting with that, so.
And every company and every evangelist has white papers or papers out. Just start reading the material, start filtering it, and some of it you're going to figure out is kind of BS, and other of it makes sense. But there's something to learn from all of it.
Learn what applies to you, what you need it for, and rely on the people around you that have been doing it longer. They will help you.
I'm going to say online. It's my thing. It's actually, I'm not the only one here, but thank you. There's resources online, YouTube, LinkedIn. You can find videos. White Papers is also another resource, online, and just kind of get a good grip of what is the fundamentals of this. And from that, you can start to talk to surveyors, and now you've got actually a little bit of knowledge based off the resources you found online to kind of ask questions and see what, the local laws are in your state based from, the information that you found out, and then get those specific answers from the surveyor or the specialist in your state.
A lot of things that I think we also need to look at professionally is really understand our clients and what their pain points are, what their needs are. Mm-hmm. Because sometimes we think, well, we're their surveyor and they should know that. But realistically, we need to know what the purpose of their GIS is, or when you laser scan something. A lot of people will make a model, and I can remember a long time ago talking with a company that had a scanner out. They were the first in the group, and they were talking about modeling everything. And I remember saying that at our company, we're going to use every piece of data we can. And today, we can do predictive structural crack analysis with scanners. And being able to look at the steel and not just measure the cracks that have already been pointed out, but being able to look at the steel and show them where the steel is warped and distorted beyond design tolerances, but no cracks have been identified. Trying to find out how we can use the technology, not to replace what we do, not to replace a point-to-point survey, but what's all that extra data trying to tell us, and how can we help our clients more?
Love it. Yeah, well, I think we've covered a lot, and I think it's why this relationship between technology and survey is so important, is that, as we've talked about, I see the need for survey to adopt the technology, and we need to bring more young people into survey, and then vice versa. The technology is growing. It's getting into the hands of a lot of people who don't understand methodologies to keep accuracy, and the use cases behind all the technologies are growing. And so I think there just needs to be a continuous conversation going between, survey and all the tools, and how do we achieve the accuracies for the different use cases, because the demand for everything is going up. And again, if surveyors are retiring and not coming in, and the demand is going up, someone has to fill that gap, which right now is not just surveyors, it's a lot of other people. So I think that survey can really play a strong role in helping guide the accuracy conversation for the whole reality capture industry.
I'm going to add to that, just because I think I'm the youngest one on stage. Well, many of you look very young. I'm not going to say you guys are older, but right. I would say that what really got me into the industry was my father, right? He was a surveyor. He loved what he did. He found a purpose in his career, and he loved it so much that he forced me into it. And I'm not gonna lie, he's retiring soon, it's fine. He forced me into it, and he made me, fall in love with it, because it truly is a wonderful career path. So I encourage anyone that is in this field, even if you're not a surveyor, just reality capture in general, push the narrative on your kids, push the narrative on your neighbors' kids, push it on any kids that you have in your life, because it really is a rewarding field. And if you throw enough mud at the wall, some of it will stick. And I think you're gonna bring up somebody that's really gonna love this field and go into it when they grow up.
Yeah, no, that's a good point. I think it's just a mentality or a generational thing, I feel. I was once told that I was lazy because I was LiDAR scanning a bridge before, and it, you know, I thought that was pretty funny, but it's just the way people see things. They don't want to see this technology come and replace what was. If we look at surveying and where it was for a while, you know, it was increasing, but in the last 20 years, it's skyrocketed, right? And so I think it scared off a lot of people. I started to recognize that I had an advantage even as a young surveyor, even before I was licensed, even because I was able to use Civil 3D. And I was at a conference talking with some other surveyors and talking, you know, I'm all excited because I'm using Civil 3D, talking with somebody, another surveyor, and they're like, nope, I don't even touch Civil 3D, you know, and I'm like, why? Oh, no, you know, I don't want to. And I'm like, you know, but I think it's, at least for myself, I grew up, you know, playing Oregon Trail and being on computers and starting from there. So it was an advantage going into the world now, where my old chief, you know, he was a heck of a boundary surveyor, but I knew how to calculate distances on the data collector, where he could look over there, or he already knew how far that distance was. Dave, that's about, you know, 1,756 feet. And what do you think? And I'm over there on the side checking the distance. Oh yeah, that's about, you know, so it's just, it's $1 million question, really, and I don't think there's a straight answer to that, you know, because how do we get this new generation? Of course, educating, telling anybody that's willing to listen, basically, about how wonderful surveying is, and also being a great example too, and being open-minded, I think, is huge too, so the next generation doesn't see that, you know, you're scared of some changes. You know, we gotta constantly be evolving. And even after we fix that, well, guess what? There's going to be more challenges even beyond that. What's the next thing that's going to come up? You know, 50 years ago, to tell some surveyors that we were going to be using satellites every day to do our surveys, they would have never comprehended. So here we are in 2023. What's it going to look like in 2050? You know, we're just going to have to keep evolving.
Back to the point of license. So there's 35,000 licensed surveyors in the United States. 44.8% of them are over the age of 61. We're going to lose 15,000 licensed surveyors in the next 10 years, and there's about less than 1,000 taking the FS, and there's less than 500 taking the PS. So we're already at a net loss of 1,000 a year right now, and so it's only going to get worse.
Yeah.
And so finding surveyors that can adapt quickly and grow the profession quickly is the number one goal.
Current surveyors, we need to understand that we need to charge more money.
Absolutely.
So we can attract young talent.
100%. I just celebrated last week. I just finished 28 years in the profession. I started when I was 19, so it got a long way to go.
And I can speak firsthand. Technology is the reason we're attracting talent. You know, the younger guys,
100%.
I want to fly a drone. I want to, what's the scanning stuff, and giving them some creative freedom, giving them trust to explore and try new things and test and validate. Like I was telling Bailey on my team today, it's the excitement in their face when they've like cracked the code. You know, it's.
So when you talk to your client, you need to understand that if your client is better at speccing, buying, and managing surveying services, they can better control their schedule, their budget, and their risk. You know, I told the story to somebody today that on a skyscraper job, the plumber put 2 punch outs in the wrong place, and they used one of the 3D models to catch it that was in the wrong place. and to correct the location was $17,000 a piece. That's $34,000 for laying out the deck on one skyscraper. Can we charge that in surveying?
To your point, we had one incorrect nail on a job. It happened to be a sewer line under a lateral bore under a railroad track. That one nail cost $75,000.
Yep. So the cost of not knowing your data, or constructing without data, or trying to use a scanner and build off of data that you don't know for sure where things are at, there's a lot of risk involved. And I know we're a little bit over time. So we are going to wrap up, but thank you guys very much for joining the survey panel this year. And I'm sure all these guys will be hanging out. Those that have more questions, we'll just keep this conversation going off stage. Thank you guys very much for joining.